What if I told you that a massive school of fish isn't led by a single leader, but by a set of simple, invisible rules that create one of nature's most mesmerizing displays? Picture this. You're diving in clear blue waters when suddenly, a shimmering wall of silver appears. Thousands of small fish moving as if they share one mind, twisting and turning in perfect harmony. They flow around obstacles, evade predators, and change direction instantly, without any apparent signal. For centuries, this behavior baffled scientists. How could creatures with such tiny brains coordinate so flawlessly? The answer lies not in complex communication, but in something much more elegant. Let's dive into the hidden world of fish schooling and discover the simple principles that create such breathtaking complexity. It starts with understanding what a school really is. This isn't just a random crowd of fish. It's a highly organized, dynamic structure where every individual follows the same basic programming. Early researchers thought there must be a leader fish giving commands, or perhaps some kind of telepathic connection. But when they looked closer, they found something far more fascinating. The true magic happens through three fundamental rules that every fish instinctively follows. First, stay close, but not too close. Each fish maintains an exact personal space bubble. If another fish gets too close, it moves away slightly. If the distance grows too large, it moves closer. This constant adjustment creates that fluid, evenly spaced formation we see from the outside. Second, match speed and direction. Fish are incredibly sensitive to the movements of their nearest neighbors. When one fish turns, those beside it detect the change through water pressure and visual cues and adjust almost instantly. This creates a ripple effect through the entire school, allowing direction changes to spread in fractions of a second. And third, avoid collisions at all costs. This might sound simple, but it's where the real intelligence shines. Fish don't just dodge each other, they anticipate movements. Their lateral line system, a series of sensitive receptors along their bodies, detects minute changes in water pressure, letting them feel the movements of nearby fish before they even see them. Now, here's where it gets even more interesting. These three rules create emergent behavior, patterns, and capabilities that no single fish possesses. A school can make collective decisions, like which way to flee from a predator, without any individual fish being in charge. Researchers have shown that just 5% of a school needs to decide on a direction for the entire group to follow. The rest align through those simple rules of attraction and repulsion. But why do fish school in the first place? The advantages are staggering. From a predator's perspective, a tight school can appear as one large, intimidating creature. It creates confusion, too many targets moving too quickly to focus on any single one. There's also the many eyes effect. While a solitary fish might miss an approaching threat, in a school, if one fish spots danger and reacts, the entire group benefits. Some species take this even further. Certain herring schools can perform what's called a flash expansion, where they suddenly scatter in all directions, creating a blinding silver explosion that disorients predators. Then, moments later, they seamlessly regroup. The precision of these movements is breathtaking. In laboratory studies, high-speed cameras revealed that fish can respond to a neighbor's direction change in as little as 15 milliseconds. That's faster than the blink of a human eye. This lightning-fast reaction time is what gives schools their fluid, wave-like motion. But schooling isn't just about defense. It also helps with finding food and navigating currents. Fish in schools can cover more ground when searching for plankton patches. They also experience hydrodynamic benefits. Swimming in the slipstream of the fish ahead reduces energy expenditure by up to 20%. That's why migratory species often travel in schools. It's literally easier swimming together. What's truly remarkable is that this complex behavior emerges from creatures with very simple neural wiring. Fish don't need to think about schooling, they feel it. Their bodies are fine-tuned instruments responding to the subtle physics of their environment. This brings us to perhaps the most beautiful insight. Schooling shows us that you don't need a central controller to create coordinated, intelligent behavior. From bird flocks to insect swarms to fish schools, nature repeatedly uses simple rules followed by many individuals to create stunning collective intelligence. The next time you watch a school of fish moving as one, remember, you're not seeing a leader giving orders. You're witnessing thousands of independent decisions made in milliseconds following ancient biological programming. It's a dance choreographed by evolution itself. What other animal behaviors leave you wondering how they work? Share your favorite natural mysteries in the comments. And don't forget to subscribe to Pet Mind Reader for more insights into the hidden intelligence of animals.